Theoretical recap. On modern Linux systems, Systemd is the init system and service manager, PID1. A service is a unit described by a unit file, usually ending in service, located under /lib/systemd/or/etc/systemd/system/. The core mental model is to distinguish two independent concepts. The runtime state, is the service running right now? And the boot state, will it start automatically at next boot? You control the runtime state with systemctl start, systemtail stop, and systemtail restart, and you control the boot state with systemtail enable and systemtail disable. These are orthogonal. A service can be running but disabled, or stopped but enabled. Use systemctl status service to inspect the current state, the main PID, and recent log lines, and journalcl use service to read the full journal of that unit. A common beginner mistake is confusing enable with start. Running enable does not launch the service immediately. Use enable now to do both. Another mistake is forgetting systemctl daemon reload after editing a unit file. Security-wise, an unnecessary enabled service widens the attack surface, so knowing how to reliably stop and disable services matters. Mini example: sudo systemtl start SSH starts SSH now. Sudo systemtl enable SSH makes it persist across reboots. Systemtl is active SSH and systemtl is enabled SSH. Confirm each state separately. Workshop brief. The goal of this workshop is to make you fully autonomous in controlling the lifecycle of Linux services with Systemd, and to make you reason like a security practitioner. Every running or enabled service is potential attack surface. You will practice starting, stopping, restarting, enabling, disabling, and masking services, and you will document the difference between runtime and boot state through direct experimentation on a real system. Work in a disposable environment. A Linux virtual machine, Ubuntu/Debian recommended, or a container you fully control. Never experiment on a production machine. First, choose an existing installed service that is safe to manipulate, for example a locally installed web server such as Nginx or Apache 2, or the SSH service. Before touching anything, capture the initial state with systemctl status, systemctl is active, and systemctl is enabled, and save this baseline in your report. Then carry out a sequence of controlled experiments, and, for each one, predict the outcome before running the command, then verify it. Start the service, stop it, restart it, and observe the PID changes. Separately, enable it and disable it, and after each action reboot, or simulate the boot state check, to prove that the boot behavior changed independently of the runtime state. Deliberately create the four combinations of active/inactive, X, enabled/disabled, and record how you reached each one. Explore systemctl mask and systemctl unmask and explain, in your own words, why masking is stronger than disabling from a hardening perspective. Finally, adopt the security angle. List all currently enabled services with systemtail list unit file state equals enabled, identify at least two you consider unnecessary on a hardened server, and justify disabling or masking them. Read the journal with journalcl use service to correlate your actions with logged events, and include relevant log excerpts as proof. Your deliverable is a short structured report, markdown or text, containing your baseline, each command used, your prediction, the observed result, screenshots or command outputs as evidence, and a concluding paragraph on the security implications of service management.